Welcome to the Edge Open podcast. I'm Ilhana Hodzic, your host and EMEA marketing at ADLINK Technology. Nowadays, virtualized radio access network vRAN is a way for telecom operators to run their baseband functions in software. A big advantage of vRAN is that RAN functions no longer need to be run on special proprietary hardware, but can instead run on standard service. Today, it's my huge pleasure to have my guests here with me. From Intel, Jason Tsai, and from ADLINK, Howard Chang, with the topic vRAN to break the boundary of 5G networks. And we will talk about how our edge server featured Intel SPR process to deploy the vRAN applications. So, let's get started. My first question goes to Howard. And Howard, please, can you tell us about the challenges our telco solution provider and customers face when building their 5G infrastructure?
Sure, Ilhana, it is a great place to start. So while a 5G deployment become commercialized, actually the biggest challenge for our customer is the substantial initial investment. That means money. And that is the main reason why vRAN or ORAN come out to minimize the impact. So since vRAN allows the RAN functions to run on standard servers, actually, it offers the benefits such like flexibility, cost efficiency, or also network scalability. So as an initial members for ORAN and OTII, ADLINK actually developed BBU server standard x86 starts from 2020. And we start from Skylake HD, Ice Lake D to the latest 4th gen Intel Xeon Scalable Sapphire Rapid EE. So powered by Intel vRAN acceleration technology. Our vision actually is to accelerate vRAN adoption with our complete BBU product line, make 5G technology more cost efficient, then further benefit the whole human beings to enjoy the cheap 5G technology.
Thank you very much for a great explanation, Howard. And I would like to ask Jason. And first of all, thank you once again, Jason, for joining us today. Can you please tell us what are the benefits that fourth gen Intel Xeon scalable processor provided?
Yeah, sure. The fourth generation Intel Xeon scalable processor with the vRAN, Intel vRAN boosts are designed for the powering the Cloud RAN vRAN, and then that they include the powerful features that the optimize workload performance for packet and signal processing, load balancing, AI, machine learning, and for implementation of the dynamic power management. So these processors deliver up to twice the capacity without increasing the power consumption for vRAN workloads as compared to the third generation of the Intel Xeon scalable processor. And this, effectively supercharges the communication service providers, vRAN deployments with up to twice the performance per watt to meet their critical performance scaling and energy efficiency requirement. What's more, Intel vRAN Boost fully integrates the vRAN acceleration in the fourth gen Intel Xeon SoC, eliminating the need for an external accelerator card. So this architectural enhancement results in an additional compute power saving of approximately 20%. Which is above and beyond the fourth gen Intel Xeon platforms already outstanding performance per watt gain, right? And it also greatly simplifies the solution design by reducing the number of components required, which provides additional benefit such as 4 areas, simplifying the system integration, and lowering the bill of materials costs and both complexity and the reducing supply chain complexity. And last but not least is helping the COSP reduce their total cost of ownership.
That's very well explained. Thank you, Jason. So I'm coming back again to Howard. Howard, can you please introduce the special designs of MEC 7120?
Sure. So MECS 7120 actually is part of ADLINK's H server family, designed specially for 5G BBU applications. And it is based on the latest Intel Sapphire Rapids EE CPU that Jason just mentioned. Okay, actually, our main idea is to help our customer to lower down the cost, just like the benefit brought up by Jason. Okay, so no matter from hardware's perspective, deployment's perspective, or operations perspective, we want to help customer to lower down their TCO. Okay, so take the hardware cost perspective as the example. So in order to leverage the existing 4G infrastructure to lower down the initial investment to building the 5G environment. Okay, we support up to 3 full high PCI slots. So for NSA deployment, actually the PCIe slot can be reserved for both 4G and 5G accelerators, as well as the frontal cards to minimize the initial investment amount. Furthermore, if we adopt Intel Sapphire Rapids EE CPU, which already has the accelerator embedded, we can save the discrete accelerators, and all the 3 slots can enable customers to install more front-hole interface cards that can provide the rich capacity and fully utilize the platform computing power. So this is from hardware perspective. And how about operation and deployment perspective? Actually, there are so many details, and here I just raise 1 or 2 examples. Okay, for example, many deployment sites actually is at edge instead of the well-conditioned data center. Okay, it may be on the top of the mountain or like the top of the buildings. Okay, so being able to accommodate wider operating temperature becomes a key aspect. So MECS 7120 supports operating temperature from -5 to 55 Celsius degree. So that can eliminate the need to build dedicated climate control server room, and it is also regarding to the money, right? Some spatial design, we have the additional accessory developed based on customers' feedback. Okay, that is a spatial kit. That kit we can keep the memory in place while server is being shipped with less ideal situation. You know, for edge deployment, actually the deployment sites are so diversified. Okay, so that may ship by like FedEx or some other express. Okay, so since it is the less ideal situation, we found there a lot of problems. DIMMs module are loosened during the transportation. So actually, we design this kind of the spatial kit to fix the memory, so that can lower the DOA rate caused by the memory displacement. Okay, so we can also offer the flexibility with the reversible fans. Okay, why? Because when the unit is set as a 5G BBU unit, we can have the airflow from IO side to the rear ends. Okay, but when the unit is equipped as a GPU card, okay, for some of the edge acceleration for some of the specific application, actually we can reverse the fan, okay, and make the airflow from rear side to the IO side. Okay, so that giving us and also our customer the flexibility for different deployment scenario without changing the hardware itself. Okay, it is easily to change the airflow while change the fan direction. Okay, so customer can do it by themselves.
Okay, there's so many information, Howard.
Yep.
For Jason, Jason, during our preparation for this podcast, you mentioned that you visited MCC Barcelona two years ago. And also we at ADLINK know that Intel already launched 4th-gen Intel Xeon Scalable processor at MWC last year. So could you please share some deployments so far?
Yeah, sure. Last summer, Intel actually announced the commercial availability of its first generation Intel Xeon processors with the Intel vRAN Boost. The code name is Sapphire Rapids EE. And then this is featuring the fully integrated layer 1 acceleration by eliminating the need for the custom accelerator cards and allowing operators to consolidate all base station layers on a common virtualized platform, right? So these chips, deliver up to twice the capacity for vRAN workload compared to the previous generation. So allowing the operators to double their number of cell sites or subscribers, and they provide an additional 20% reduction in the vRAN compute power consumption by removing the custom ASIC silicon to reduce the system capacity and the BOM cost, right? So, and last year we also saw that Ericsson make its first Cloud RAN core on the processor, and Verizon also announced that the industry's first data session on the processor, using the Samsung's vRAN software. In addition, AT&T and Ericsson unveiled plans to deploy and scale Open RAN services in collaboration with Intel, right? And Vodafone also began the volume deployment of Open RAN in the UK. So, it's an early Open RAN deployment, based on, the third generation Xeon processor demonstrate the performance exceeding that of their legacy equipment. So this year we are excited to announce that the operators are proving the validity of vRAN Boost in the large-scale urban deployments. So having completed the industry's first commercial data session of the vRAN Boost with Samsung, Verizon priced the meaningful power efficiency gains, the ability to manage higher workloads and higher throughput performance.
Okay, you got so many deployments so far. Well done. I guess we reached out to the end of today's session. I would like to thank you both, to Jason and to Howard, for the participation in this podcast, as well as I want to thank to everybody for tuning into this episode of the ADLINK Edge Open podcast. We hope you have gained valuable insights from our conversation with Intel today, and also please stay connected with us for more thought-provoking discussions on the 5G solutions, as well as we invite you to visit us at NWC Barcelona this year to learn more about the private 5G and industrial edge computing solutions. Thank you once again.
Thank you.
Thank you.